Can you see? Hello, hello. 1, 2, 3, 1, 2, 3. What? One, two, three. Can you go out and listen? Can you listen? One, 1, 2, 3. 1, 2, 3. 1, 2, 3. Delay. Lagging. 감사합니다. Okay. Can you listen the voice? Hello, 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 hello. Voice check, voice check. You listen the voice, right? Yeah. Okay. Can we start?
Please.
Good morning, everyone. Today I report what I did last week. So I keep learning about probabilistic time series forecasting, as mentioned before. I keep reviewing some papers that I just report, right? The review from the last seminar with Sumi, and we try to another design the ITIC distribution. So I just summarize what I study. So I summarize here the form of the probabilistic forecasting method. We have the two types for the univariable and multivariable. And as mentioned earlier, I try. This one first. As mentioned earlier, I try to study the next paper I want to design about a multimodal. So and also one of the tasks required is the probability forecasting. So that's why I keep studying about forecasting. See the reason. Okay. So back to the ITIC the design. So I already discussed with Dr. Yu and also the Zahid. So and especially the Vu, Dr. Vu, we have the two way to solve this distribution. One we use the API, and one we view from the scratch. So what we use API, what I can find here, we have the many, but only the clean AI and PCAR, and another is the view. Most of them they are from the China, of course, and they have support the thing like this. We can input the one image, and we can input the prompt. Then we generate the video. Start from this initial image. So if we use the kind of the API here, we need to pay the price. They will give us some several times trial, but after that we have to pay. Actually now I'm keep running the generation the video, but usually it takes 24 hours. without payment. The second thing is that we can view the generate the video from ourselves from the scratch. So we have the many open source what I find here, but it takes a lot of time and efforts. So as everyone know, so I designed the front end for the short time that we can show up and show up what we will do, and also we can write the documents for submission. We imagine the task what we will do, like we have the we can enter the prompts here. We select the how long video we will generate and what type of the video we can generate, and then we can upload the one photo as the initial starting frame, and user can generate a video when they click the big button. I already showed a demo for Dr. Yu, he a little bit satisfied, and in this front end, I designed two types. So if in the distribution we can bring our server and our model can work well at a time. When we click this one, we can call the model that at the time I will use the Zahid model, the diffusion model. Otherwise, if they provide, of course, a backup plan, we can call the API at the time. Or backup plan is we can make the video first, generation first, and at the time, yeah, we just show on the screen. No user interactive at the time. So we have the ABC plan. Okay. Okay, mentioned earlier, and also the plan for this year. What I want to do is the multimodal time series. Especially now I have brought with the two times. This figure I draw it. So imagine what I will do is the time series data and text data. So I want to use the LLM in this case. So LLM specially designed, for the text, and of course they also allow to adapt other the data. But I want to use the text data with the LLM here, and for the time series data, somehow I will use the traditional data what we already have on the market. What we have already researched is the Llama, for example, is quite the SOTA foundational model, and we will find a way to fusion that we have the reasoning, the output. Earlier, Dr. Wu and Dr. Yu already joined my last meeting paper review recently. So I already mentioned the big picture about the time series reasoning. So you guys also know that. So because of this plan, so you can see I need to know how to implement and run the LLM, right? So this is the normal thinking, backward thinking. So I give you one of the many images you can see. Usually for the rack or any like AI agent or any the application that we use nowadays using the LLM, always they have what character they will use. Vector database, of course, right? But this is not our research and also not my plan. So I don't care much vector database, embedded model, or other thing. But the thing I want to say here, how we can deploy or running or tuning the model easy. So nowadays, the community where they want to use the LLM run locally, okay, they use the term Olama. Olama now we can handle many types of the LLM model. So Olama is the tool to design the run open source LLM model locally on a machine. I don't mention about the cloud or calling the API. Okay, it's different with the LangChain you know, when we work with LLM, of course we need to use the LangChain, but LangChain is a framework for application level. Okay. So I spent more time for the last week to study and how I can deploy my LLM because I have quite good server. So I believe I can run with Olama. So recently, Olama can handle many type of the available on of the LLM model here. So this is the last the last month. So the new one model now we have like DeepSeek. Okay, we have DeepSeek is the top one open source the LLM recently. So you can see how the Olama handle. Olama can handle to deploy and run inference the model locally in the very few lines of code. Okay, and it's kind of when I run, I feel Olama is kind of like a Docker style. Everybody don't care about this one is the Kubernetes and another thing is kind of Docker. Okay, but I say here. I deploy on my H100 with the Olama and maybe you know open source the web interface. This is a tool quickly we can have the UI that we can interact like a chatting or the thing without like using the terminal. Okay, I deploy the model with the 60 billion parameter quite tall. The DeepSeek are one, but you guys know it's consume only a half of the V memory required for running the DeepSeek. But you know what? Even though we can deploy, but the speed is not than what I expect. So here is I finished the way I can show here. You can see this is my the local here. I use the earlier I say the I/O open interface, open web interface, and the model what I success deploy. I'm using the DeepSeek R1 with the version of the 60 billion parameter and run very well. So that's all I tried for the last week to focus my plan. So the next step, of course, I will do the fine tune the LLM, and then I will introduce you guys the paper named that they use the time series data with the LLM, and we have hopefully I can have the experience as soon as possible. That's all my present. Thank you.
Thank you. Thank you your presentation. I can feel it's mixed the research and the development and we can call this engineering. So it's quite interesting. Maybe another big laboratory and another team maybe already did this way. I think this is also one of the research topic nowadays. So you can focus and maybe I just worried one thing like if you handle the big models, you just show the example of the very is enough the computing source, but I'm worried about this computing source. So we will discuss together.
Yeah. Maybe in the future we cannot run really because we integrate another the foundation model, so we quite bigger. So at the time, maybe at the time LLM will select a smaller model like just a 1B or 7B, for example.
Anyway, it's quite the first step in our laboratory.
Yeah. talk a lot about LM, but nobody take actions. So I just try to do what it is.
You show the like the GPU utilization in the next slide. So question, as I understand, you did some training on the Olama, right? Can I ask?
Yeah, okay. Olama actually for not training. Olama for deployment. They support the training, but I didn't do here. Okay, I just deploy.
But the deploy like a, that means the in the inference at least needs the 40 gigabytes to bigger, right?
Yes,
Um,
inference
Only
place. Of course, it is the case when you think training maybe require 10 times or 100 times bigger, depends on the path size.
And also the previous slide, I think, and the one more previous slide. Can I ask in the multimodal, there's a reasoning output, right? I think maybe I already asked this question before.
Okay.
Reasoning output is can be the what task, like anomaly detection and the time series forecasting.
Or time series reasoning. For
Yes.
example.
Previous the multimodal like a structure in the slide you showed. At the time the result was the reasoning output.
Which one? This one?
Yes, the reasoning output.
Yes.
Reasoning output can be the text, or it can be the time series forecasted the time series data or anomaly detection,
Okay.
or it depends on the result.
Okay. Yes. So far I didn't define my task yet. I just have the idea how can I use the multimodal, and if future I will specific the task, but I can say to you because today I introduced one paper with the tool about this kind of thing. So you can imagine some use case like this. People insert the time series, for example, finance, the stock, for example, they insert the list of the time series, historical data, right? So traditional task forecasting or classification, whatever, right? So the new thing now is to add more information like articles or some image or some information, whatever you have, add it, and you can see output explain the next why we have this result. Like okay, I will forecast the 7 day go up, but why go up? What is the point make you go up? So this is the thing we say reasoning.
Because reason why I ask is now I feel that even if you use the same multimodal like image or image as a text, image and text, output depends on the output. The structure or research can be like a little bit different. Like in Lava, I previously like briefly explained. In Lava case, vision image data is kind of like assistant to make the output text. And another paper SDK something is the segmentation API model, SEM2 model, but it also used the Llama, but in this case, the LLM is kind of like assistant to make the final segmentation detection. So depends on the target, the structure and the fusion, or which pipeline we train or not can be like a different. That's why I asked this question. Thank you for the answer.
I see. Yeah. So that's why I just make the really simple diagram here. Go to detail, it depends on the task. By the way, can I ask like with the lava, what is the output?
Lava is text vision. They focus on the text. In the paper they say it's the vision assistant. So the large language model and the vision assistant, the short term is the kind of lava. So anyway, their target is to make the better text generation on the image. But anyway, they use this the image encoder as like an assistant.
Okay, so can I understand? Image original is the NLP, the text, and the input data is the text.
Final generation is the text.
Yeah. Input is the text, and image the assistant adding more information, right?
Yes.
Or image or the main data.
Image also can be the prompt, or image can be also the inside inference part. In the training part, they also use the other images.
do they select which one is the main data, like adding weight 0.6, for example. Must focus only this one, the like image or text, for example, or do you know about it?
I think I have to find more details.
Yeah, actually, it's still my question. Sorry to ask you. I also try to find the answers and share with them. Okay, thank you.
Can I share my understanding by the system? I can show the some sample. So like Mr. Jin and and say, I discussed with Andre how we can apply the LLM model or reasoning task in the time series. So and like Jin already mentioned the LLVE. So in the we are talking about this the large language and vision assistant. So the keyword is the visual injection technique. So I give the idea to add the injection technique, but we replace the visual by a time series. So for working with this test, we need the data set. For example, our VL part data set is the one kind of data set, but our data set has no reasoning the data. Reasoning data means like for example, Jin one time share this data set. So this, for example, this data set is the collection of the face and the description of the face. So when we use the data set through the intuition technique of the LLVE, it becomes like a face intuition like this. Or another data set in the maybe this data set and yeah, kind of I have like in the smartphone we have like this data set. So what's the meaning of the reasoning? Like we give the image in the visual, we give the image, and we can give the version, and the model can like do the pattern checking with some kind of the reason like they in this paper like they mentioned like they use the external knowledge from the wiki. Like this. So we try to kind of create like follow this type of paper, making the data sets with the time series and the reasoning test. So when we try to link the Python intuition tuning with the model, we can add like from like a thing step by step. So at that time, the model will automatically generate like a chain of thought, like this, but how the model can generate the chain of thought? Actually, the user should fine-tuning it with the data set. So in the data set, we should create like a kind of chain of thought, like a dialogue first. So this is our kind of the output of the framework. Create the data set first. Very similar with our current multimodal paper. But the algorithm multivariable, we are stop and just the fine-tuning the clip and only on the captioning data set. So our model only have the our function our model function only can simply query retrieval the image, cannot do the like turn by turn chatting like this. But like Jin mentioned, the LLVA model, they had the function of the line by line turn by turn chatting. The user give the image, model return the output, and ask again and return, ask again and return. Yeah, generate text. So the output is the text or explainable text. So time series also the same thing. Give the time series and we can query about information like can you give the prediction of the 10 days later, depend on it. So maybe the model at the time the models will prove for us like depend on your data set and depend on my knowledge at the end of the January there are some events. So I will give the prediction generation. The next 10 days will be according to the existing values. So the output still the text. But how we can evaluate this type of the output? So normally the LA model also should have a prototype for analyze the key data. Like I said, like after they return all of the text output, right? They will provide all of the unnecessary information. They only keep the prototype, for example, like a 15 number 16 calculated, and after that we can evaluate.
So it is for time series data.
Oh yes.
So what is the purpose?
Purpose?
Yeah, what an LLM do after we train it on time series data?
So I think first our purpose is not very clear, but we want to try use the foundation model or big language model to the time series data, because I mentioned the type of the paper they already kind of the fine tuning the research language model on a specific domain type that is. So we also want to try to follow this type way, fine tuning the time language model in some specific domain or data. Try the IDT to try and make the data sets and study.
Okay. Thank you for explanation.
So my view is our laboratory can somehow color together.
Yeah, this is what I also really recently I worked with Dr. Wu extremely to go deep with this idea. Anyway, I remain 1 year, hopefully. So I want to set up this year. I want to get the output as soon as possible.
Thank you.
Please.
One second.
Okay, so I just found this paper yesterday, and it is published by Google Research and CVPR in 2023. As we know that the current problem in diffusion model is training it or fine-tuning it. Even if we fine-tune it, then it takes or require considerable amount of GPU time investment. So to solve this problem, they have proposed this hyper dream boot. As we know that dream boot is a diffusion model. And after that, they propose this hyper network, which is capable of efficiently generating a small set of personalized weights. So directly giving it to a diffusion model, image features, they are giving the learned weights. And after composing these weights into the diffusion model, the hyper dream boot can generate images in various contexts and styles while preserving the important details. This method achieves very fast fine tuning, almost 25% faster than the dream boot method. This is how the model works. They have a hyper network, and the text to image is the diffusion model. So the hyper network just takes around 2 seconds to generate the weights, and then these weights, when fine-tuned with the diffusion model, it's almost like 22 seconds. So almost 24 seconds, it can generate a bunch of images giving a prompt. This picture shows two stages. One is the training. In the training stage, we can see that they have built a hyper network model, which is a deep learning model, obviously, generating weights from the images, and then they have some ground truth weights. So we have to study this. What is this ground truth weights? Like, it is some kind of levels maybe, because if it's like they are saying ground truths, then maybe some kind of learned weights. And when they are feeding the images to the hyper network, which is their developed model, they are generating the latent features from it, and then they have a reconstruction loss. Similar to MSC, they have their own type of loss, which is mentioned somewhere here. The vanilla diffusion reconstruction loss. And after that, the weights, the learned weights are then fine-tuned with the diffusion model, as shown in the AV. We could be like multiple prompts. And in the fine-tune, we can see that the hyper network is blocked, meaning it is frozen. And in the hyper tuning method, only the weights are feed into the diffusion model. And in that case, we also have in the training phase, we also have the diffusion model completely frozen. In the fine-tuning phase, we have the diffusion model completely frozen. And this is how we can see that in the fine-tuning phase, different phases can be generated. This is the training architecture of the proposed hypernetwork model. First, images come to a visual transformer encoder, and then linear embeddings are generated from the images. Then some weights which are initialized zero weights, means it could be initialized like randomly, but they have initialized from 0. And then they have a transformer decoder, which goes to the which is predicting the weight 1 and weight n. So transformer decoder is decoding the phase features along with the weights which were attached in the training phase, and then multiple iterations. Obviously, the training phase to learn the weight features, and finally the weight features are output. This is the comparison of LoRa Dreamboot. So in the LoRa, they have some kind of single encoder maybe and single decoder, which they have shown like down and up. And here they have proposed a down and then a down. So we have to first clearly, as it is a little bit complicated, this diagram. But we can see that some of the training part is frozen in the hypernetwork model 2. So this is what I studied just from yesterday, as we are preparing some idea for the exhibition. So I'm studying it along with my other works. So that's why I did not include the other works. It will be going parallel. Both works will be going in parallel. So I hope so from a friend we can have a good idea to represent an exhibition.
So for the new project, you originally you just made the concept of the stable diffusion tuning, but you can find some hyper network
Yes.
using some stable diffusion model, right? So you can keep studying, and but parallelly you should make the result with the stable diffusion tuning with the anyway, because we have some deadline. So I hope you can finish. We can get a small result. And this.
How was the training yesterday?
Right.
You run the some.
We are using very log-based model for this training.
What
So-
model? What model?
It is the stable diffusion 1.5. So we can just like the old artistic type of images we can generate, but we cannot generate realistic images. So it will be like artistic style in the old style. It is colorful but not clear images. Rather artistic style. So if there is possibility, we can use that, or we can slowly, because it is the learning path. We are learning how to fine-tune the model. So gradually we will move to the good model.
Anyway, I also understand the stable diffusion is we cannot estimate how much time finish the model, right?
Yes.
You can carefully check and share the result with us in the any time.
Because the abstract is video generation, but like now you are do this problem of the image. So do you think from the image to video is a simple text? Or now you like how you can stack with like a video generation image?
Well, I think there is no stable diffusion model to generate videos. Yes.
But the for align with the ROD mode, it should be the big video generation.
Actually, in the proposal, I said the image or video. I already made some option, so it's not.
Or we can go with the gains.
No, I think the stable diffusion is good. But so if we are only use the like for example now you only have the image generation model, so I think about saying how about we can make the two state. So first is if the user just to put the image, the face release image, and then use your stable diffusion model, we can generate the kind of, and with this aspect we can put into an API to generate the like a short video. Because I checked, I didn't check carefully, but when I saw the website, I checked the data sample. The sample is when they upload the image, this image is not like a realistic image. Like I also generated by another
Anime or something.
Yeah, so I think maybe the API will work well on that type of data set, but maybe it not work well on just the realistic the image. So maybe your after training, your model will be the first step. But okay, after you also mentioned that if we just stop at the image, your model is enough. Or if we just stop at the API and model is enough. Anyway, after you finish the plane, so now only focus on making the outlook. Thank you. And the dream boot, the high hyper dream boot with good component, with conference.
Conference, CVP,
Good year.
this paper,
Oh.
2023.
2010. Because I remember Dream Good in a very famous paper, they received the award from like a very young researcher. They
Actually, when they launch a diffusion model, they don't keep it aside. They are refine-tuning. So, like one version introduced in 2021, second 2022. So, same model but refine-tuned.
Okay.
And if you need anyway, our content is the Korea drama, some Korea drama from your idea. So if you have some if you need the help from the Korea drama content or
Okay.
something, let us know.
Okay, thank you. Okay, fine.
Oh yeah. Thank you.
Thank you.
Yeah.
Related to the previous multimodal presentation, I can briefly introduce the related works multimodal with the SAM. This is kind of a little different from the reasoning and making the charcoal. In this case, they use to the purpose of this is using the SAM tool to make the segmentation output. In this work, they also the fusion in the OpenAI clean model, and this is the downside is clean model, and this is M2 to make the automatic annotation. To make the easier annotation, this is kind of like a text assistant cases. The A part is just the SAM2, the automatic segmentation. In the SAM2 automatic segmentation, they do the inference on the image. In this case, image every grid to use as a dot prompt, and after that they make the many mask and do the non-maximum suppression to make the only few segmentation masks. And finally, they make the result. In this case, they use the fusion embedding in this paper to embedding together to the text encoder and the image encoder, and make the final output segmentation mask, and the detection layer based on this caption and the data. So when we use the multimodal, it depends on the task or purpose, or it can be really changed. In this case, there's no reasoning or charcoal or based on the text prompt. And another case is this one. This one actually, in this case, they can do the question and answering based on the scene and also on this mask. I think this is more like an advanced case. I think they need a lot of computational power. In this case, I didn't check very details about the fusion, but their result is they can understand, this model can understand just video, and also is this dense mask to make the question and answering about this. I feel really interesting in this work. So the target or purpose of multimodal, we can do many things based on this. And then I can move on to my presentation. This week I did to have some data center proposal and another my personal research and some works. Actually, in this case, I want to show in the long sequence, M2 has some limitation, but when I do the inferences work really well. Also, the some very occlusion and the reappearing case. The reason why is that I think the ground truth, the segmentation mask structure, this object just moved and reappearing, but it doesn't change, like getting small on scale, or like this. So I can briefly show the result. This is the zero shot. I gave the prompt in the eyes. Even in the reappearing case, it works really well. I keep just the one prompt.
And the
First prompt, yes, at the beginning. But I feel it's working really well, just in these easy cases. And this is the previous. I introduced another recent paper research related to my current SEM2. I think the current problem or current challenge or to this video object segmentation is the reappearing and the occlusive object that are needed to track. So previous current works of like the previously introduced the samurai paper or the SEM2 memory tree. Anyway, this kind of work is to solve this problem based on the select memory, based on the prediction of the next state, how the object will segmentation next state. To solve this problem, I think I first think about how human can understand the video. Now, when we see the video or the image, we don't just see only the pixel levels. We can infer based on our previous experience, like a texture or like how the object can move. We can easily understand, but actually it's not the thing we can learn when we only see the video. So similar to the human case, I want to use this information to inference the same object. So as you can see, like when we see the video, we can roughly guess the next movement of the object or like texture or optical information. If the light can be the different position, we can easily guess of this optical information. But the current works didn't consider just this too much. They can just like a prediction based on the traditional approach, like a Kalman filter, or prediction of the many masks. Like a memory tree. So my point is that we can add this additional information to the embedding to inference the next state, and also in this case predict the next state on the pixel level has a very risk like a computational complexity, or we cannot use the many nonlinear cases. So my point is to embed this information. Currently, the memory just use the segmentation mask, but in this case, I will use the motion or optical information. We can easily understand just based on the information, based on the video, and make it as a joint embedding, and use the particle filter to predict the next state. The point is that this prediction of the next state is everything done on the latent space. So I can briefly show sorry to this figure is not perfect. This is just the previous segmentation model. This actually just in this case just normal SEM2. Image encoder can go to the memory attention to the mask decoder. This before making the final masking output, the object pointer and the memory embedding can do the attention in the memory attention. And this the previous information and the current image embedding is fusioned in here, and then go to make the final segmentation mask. That's why the SEM2 model can easily predict the previous mask, even the reappearing cases. and this is the prompt encoder. But when select this previous memory, just normal send to pick the prompted image and recent frames. But recent frames has some limits in the very long sequence and the very occlusive or reappearing cases. So my algorithm is to how to select the previous memory. Is based not based on the pixel domain, not pixel space. The previously they used just mask embedding and the object pointer, but in this case I want to add like scores. These scores can be defined to many like optical information and the motion information, two embedding together. In this case, the previous motion scores they also the state model, so they can predict the next state. But in this case, very linear cases, so the based on these scores to embedding together by the cross rotation. And each scores can be used as one tokens, and this fusion mask embedding can be the another token to make the cross rotation to find a joint embedding. And then this the particle filter part. This is the current T frame, the joint embedding. So there also need the mechanism to predict the next state. So the prediction of this joint embedding to the next state can be I will implement as the particle filter. Particle filter is to using the small MLP layer with the noise. Joint embedding to the particle MLP with the noise and make the prediction. In training case, we already know the next day. So in this case, make the additional loss function to the particle filter to predict the nonlinear cases in the latent space. And based on this joint embedding, I will select the which memory is the most close using the maybe I think cosine similarity. So this joint embedding is kind of the key to the each frame to what is close, what is similar to the previous memories, not based on the just Abin transform or very linear cases. But when I making this kind of structure, there's many things to consider. I want to change all the memory bank part, but I also have to think this previous segmentation anything to model this the foundation model level. So their pre-trained wave is very strong. I mean the generalization ability is very good. When I fine-tune some small data set in the sense to I feel somehow when I train on the very biased or small data set, their generalization ability kind of reduced. When I train very small pure data set, only one classes, before that when I do the auto segmentation, it works really well. But when I fine-tune on the small data set, somehow their auto segmentation, the result very reduced. Their quality is not good. So I feel try not to harm this previous central architecture or very strong pre-trained way, but have to integrate the memory system. This is the one challenge. So if I train this, I'm thinking about the only freeze, the image encoder and the mask decoder, or another part, most of the parts where I will think about the freeze, the pre-trained way. And at the only training part can be only the joint embeddings. And the loss function can be the IO, first can be the IO prediction, and this the particle filter part loss, only two losses in this case. To don't harm the previous, percent to pre-trained way. And also about the joint embedding or memory system, this is only currently used for only the video prediction. Video prediction means only the sequence they're fixed. But I think for further next development, it can be done on the real-time videos. Currently, this infers only for the fixed videos, but if without harming the pre-trained weight, if changes some structures, it can be also done in the real-time segmentation. And also, even in the image segmentation, it can be used, but their baselines doesn't allow this kind of function. So for further research, first do this the joint embedding and the particle filter prediction, and then next step I can go on in this way. But implementing this idea is not easy because the SAM2 structure is kind of very complex, and I should not rewrite because anyway the pre-trained weight, for the pre-trained weight, the key names of the weight and the class name should be matched, the initializer and the key weights, the pre-trained weight. So I cannot rewrite everything just to rewrite some method or add some method for the SAM2 baseline code. So it takes some time to implement. And also what data set I should train in this can be also the important. So I checked the Metas, the SA1B data set. They open the data set, but it's not full, I think. I'm now currently checking the meta data set, open data set. And another data set, the previously used, I already downloaded the VOS data set and the MOS data set to the previous, the Samurai paper or memory, SAM2 memory tree papers. They use some benchmark. I already download and check their formats. I can do some training or memory bank initialization. I can say like this. Maybe next week, first I will finish the data center remaining data center proposal, and this the experiment, writing the code. I will slowly start and check the data set. Okay. Thank you. Is there any question?
No, visa process.
Is a process?
This is your work too. You have a lot. I mean, what he did, not her. He did.
Don't forget live streaming. Of course, I will do always live streaming.
Yeah, and thank you for your presentation. I compare you have considered a long time to design this architecture. I think it looks the high probability to be successful. But I think when you implement and when you train, maybe depend on the result, you should be discussing anything. So we can focus to start this project. I can support it.
So many things to fix, making the score based on the IOU or similarity or the fusion of the it can be depends on the experiment result.
Yeah.
I think.
I just remember there's one techniques to run the foundation model with really huge data. I forgot it. GG something. The keyword. I will send you if possible because it's concerned about the foundation. Something here is really general. Somehow it's
Yes.
required a really huge thing. That's my comment.
So I have two comments. First is this is a very interesting. You saw the example of the sound to on the running on the video like presentation. But like you explained, that is quite a simple case and it worked so perfect. So it makes your like motivation is a little bit disappear. Yeah, because your motivation is like you try to solve the problem like occlusion or disappear like an object, right? So I can recommend that when you orient the data set, you can find some limited data set and just run the baseline sum on the low data set and to see like which case, like, especially the with video had the problem.
Oh,
That-
yes.
Yeah, by eye. And also we are working with some medical data sets, so I also you can try on the medical data set because medical data sets normally is difficult, like everyone know. And one more data set is I I recommend you yesterday. You remember about the smartphone, the time lapse video. Sometimes at the night, it disappear all of the strawberry like this for a long time. Yeah, so if you also try on the digital assessment, first is the prompt on the morning, and if the tomorrow morning again the model can predict this is I think amazing model. So this kind of the difficult data set, and one more comment in you mentioned about you are designing the joint embedding space. Just a few minutes ago, we had a meeting with the A-Floor. Sunil mentioned the BQ vector one-time auto variation or encoder. So in this the architecture they have the code book. So I just think that this code book is similar with the memory system. So if you have time, maybe you can read that paper because this paper originally they developed for vision model.
Vision model VAE.
variation encoder.
Vector quantization variation of encoder something. Yes. It has many modeling too. So if we can modeling about this memory system with this technique, with the help of another senior research, I think it's good in do the modeling.
First, about the data set, I also agree. So, but the previous works have a benchmark, so I can first experiment the benchmark, and then for observational study or additional experiment. At the time, I want to try the really long sequence.
Yeah.
And about making the joint embedding, I also first about the variation autoencoder, but I just worry if the each T frame or if I pick some another frames, anyway it is computation have to be keep the, but I worry about the variation autoencoders the time inference time.
Oh, good. You already think about
Yes. So that's why when I many thinking about the deep joint embedding, this cross attention, then also like many other approaches like a concatenation or just either one product or just element-wise add many things to fusion based on the transition. For reason why there's some reasons I picked just cross attention and also the particle filter, but I can read the paper about concatenation of variable.
Me too. If I find some related point, I can help. We can discuss. Good.
Anything else? No? Okay. Thank you.
What's the name of this paper? The graph.
You can share the everything in everything. Contain these papers.
And this one is
This is you 100%.
yes, you want that much.
Good question.
One.